Hi, my name's Jake Rose. I'm a developer here at LittleHorse, and in this video, we'll be discussing LittleHorse Fundamentals. The goal for today's video is to define the 4 core components of the LittleHorse server. We'll walk through a working example to build your first workflow with LittleHorse. The 4 core components of the LittleHorse server are the WorkflowSpec, the WorkflowRun, the TaskDefs, and the task worker. To help us understand these core components, we have a diagram here of a workflow. In LittleHorse, we use the term node to represent steps within your workflow. LittleHorse provides a handful of node types to help you build your workflows, but the most fundamental node type is the task. The task node represents any work that will be executed by a computer. The TaskDef, or the task definition, defines the inputs and the outputs of a task. So the workflow spec in LittleHorse is composed of nodes and conditions, which we'll talk about later, but using these building blocks, you can represent your workflows. So if we were to define the workflow spec and the TaskDef, the workflow spec would be an API object that represents your workflow. The TaskDef would be an API object that represents a task that will be executed by a computer. The TaskDef is analogous to a method signature in that it defines inputs and outputs. In this section of the video, we'll further your understanding of the TaskDef in LittleHorse. As we defined on the previous slide, the TaskDef is an API object that holds inputs and a return type, and some other metadata about a task that will be executed by a machine. On the right side of the screen here, we can see the metadata object that LittleHorse holds. It has a name for the task, it has some input variables, it has a time it would be created at, as well as a return type. So how do you create your first TaskDef in LittleHorse? Say we have this simple Java method here that takes in a string and returns a string as well. The first step in creating your TaskDef with LittleHorse is adding the LHTask method annotation on top of your method. After putting the LittleHorse task method annotation on top of your method, you can now register the task definition with the LittleHorse server. To get a better understanding of this, let's run through the code. So here we have an application that will allow us to register our first TaskDef with the LittleHorse server. You can see the link for the code here, and it will be linked down below. The first step is to create a method, and then on top of this method, use the LHTask method annotation. For this example, we don't need to worry about the details of the LHTask worker. We're just using it to register our TaskDef with the LittleHorse server. Later in this video, we'll go deeper into the implementation of a task worker. To register our TaskDef with the LittleHorse server, we need to grab an LHconfig, create an instance of our greeter class, create a task worker with the parameters greeter, greet, and config. And then finally, our greeter worker can register the TaskDef with the LittleHorse server. LHCTL is the command line tool that allows you to manage your metadata that is registered with the LittleHorse server. To learn more about the LittleHorse command line tool, you can go to this link. The command LHCTL-help will give you a comprehensive list of all the commands that LHCTL provides. Before running our application, if we use the LittleHorse command line tool to search for task definitions within the LittleHorse server, we'll see that there's no TaskDefs registered with the LittleHorse server. After we run our application, if we navigate to the LittleHorse dashboard and click on TaskDef, we'll see our greet task listed on the LittleHorse dashboard. Now that we know what a TaskDef is in LittleHorse, let's further our understanding on the workflow specification. As we defined earlier, the workflow spec is an API object that represents your entire workflow. A step within a workflow is called a node. There are many node types in LittleHorse, but the most fundamental node is the task node. Before we create our first workflow specification in LittleHorse, there are a few pieces of information that we have to know. LittleHorse SDKs provide helper methods that make writing a workflow specification read like natural code. There are 2 steps to creating your workflow specification. Create the workflow specification logic with the helper method, and then register the workflow specification with the LittleHorse server. The workflow specification is made up of nodes that represent steps within your workflow. The task node represents work that will be done by a machine. Before we dive into the code base, I want to take a look at this code snippet here. If we take a look inside of this code block here, This is what defines our workflow specification. If we take a look at the first parameter, this is what defines the name of our workflow specification. The helper method workflow.newWorkflow allows us to name our workflow specification as well as provide the logic for our workflow. A workflow within LittleHorse can hold state and variables as well as execute tasks that you have registered with the LittleHorse server. The greet task is what we just registered with the LittleHorse server in our previous example. This code snippet creates a workflow that looks like this. You start, you execute the greet task, and then you will end. One of the many benefits of LittleHorse is that it comes with a dashboard that can give you a visual representation of your workflow specifications, your task definitions, and your workflow runs. This is the visual representation of the workflow specification from the previous code snippet. Now, let's try this ourselves. In this example, we'll be creating our first workflow specification in LittleHorse. The code can be found in this repository and it will be linked down below. To start this example off, we need to create our task definition with the LittleHorse server. You guys should be familiar with this from the example before. We have our greet method that takes in a string and returns a string. As we come over to the main method here, we can see we registered the TaskDef with the LittleHorse server as the same we did in the last example. In this example, we create our first workflow specification with LittleHorse. Our workflow specification can be seen by this code here. We call workflow.newWorkflow, we specify the name of the workflow spec, and then we specify our workflow logic. As we said prior, the workflow can hold state through variables and it can execute task definitions that we register with the LittleHorse server. We can have multiple tasks here. The order of execution of the program represents the order of execution of your workflow. So if we were to add different arguments to these tasks, we'll see that name here, the variable, will be executed first, and then with the argument Steve will be executed second, and then greet with the argument Joe will be executed third. One important feature to note here is that LittleHorse does allow for conditional logic. Conditionals will be covered in another example, but it's important to know that this is possible with LittleHorse. Workflow.newWorkflow will return a workflow. We name it WorkflowSpec Generator. Then with our WorkflowSpec Generator, we can register the workflow specification with the LittleHorse server. If we run our application here and search for workflow specifications using the LittleHorse command line tool, we can see that our greet workflow has been registered to the LittleHorse server with the major version 0 and revision number 0. To examine the workflow specification further, we can use LHCTL to retrieve the API workflow specification object. Now, when we come over to the LittleHorse dashboard, we can see under workflow specifications that the greet workflow has been registered with the LittleHorse server under version 0.0. If we tap on greet workflow, we can see our workflow specification with 3 different greet tasks. Each box represents a node within the workflow or a step within the workflow. If we click on the box, we can examine the task definition through the LittleHorse dashboard. We can see the first task accepts the variable of name. The second task uses the argument of Steve, and the third task uses the argument of Joe. Well, how do we start the workflow now? This leads us into our introduction for the WorkflowRun object in LittleHorse. So what is a workflow run? You can think of the workflow run as the object that represents your running workflow. A workflow run is a LittleHorse API object that represents a running instance of a workflow specification. LittleHorse provides a start workflow run RPC that will trigger a workflow run to be created. So how do we create our first workflow run? First, we register our workflow specification, which we did in the previous example. Then we can call the start workflow run RPC, either programmatically with LHCTL or with the LittleHorse dashboard. So now let's create the workflow run from our previous example. We can create a workflow run from the LittleHorse dashboard if we navigate to the top right and click on Execute. You can also create a workflow run with the LHCTL run command. In this example, we'll create our workflow run through the LittleHorse dashboard. Since name is a required field, we must provide a value to start the workflow. On the other hand, custom workflow run ID is optional, so we'll leave that blank. Now, let's click Execute Workflow to create our first workflow run. When we create our workflow run, we're redirected to the workflow run page. We can see our workflow run ID here, we can see the status of our workflow as running, and we can get a visual representation of our workflow run. We can see that our workflow run is stuck at the first node. This is because our program is not executing any work within the workflow. And that's because we're missing one key step. We need to start a task worker so it can pick up tasks from the LittleHorse server. So what is a task worker? A task worker can be any program that connects to the LittleHorse server. It pulls for scheduled tasks, it will execute them, and return the output back to the LittleHorse server. The output can then be used within your workflows to update variables and for control flow logic. So now let's start our task worker so we can finish our workflow run. If we come to the bottom of our program and see the greetWorker.start line, we can go ahead and uncomment that. We can also go ahead and uncomment the shutdown hook. Now let's rerun our program and see what happens. Our task worker is now running. If we come back to the LittleHorse dashboard, we can see that our workflow run is in the status completed, as well as all of the tasks have been executed. If we click on the task and go over to node run, we can see the task output. Now to end it off with a little review, the WorkflowSpec is an API object that represents your workflow. It can be configured through the LittleHorse SDKs, either Java, Go, Python, or .NET. It allows your workflow logic to be consolidated to one place instead of being spread throughout many services. The TaskDef is an API object that represents a task that will be executed by a computer. The TaskDef is analogous to the method signature in that it defines inputs and outputs. The workflow run is the running instance of our workflow specification. It holds state to depict the status of your running workflow. And finally, the task worker is the program that pulls the LittleHorse server, asks for tasks, executes tasks, and reports the output back to the LittleHorse server. And that's all we have for this one. Thank you for watching. If you're interested in learning more, feel free to join our community Slack and check out our GitHub repository. They'll be linked down below.